Hello, today we will see another application of non-destructive testing with microwaves. It is the moisture measurement. For the introduction, I take some words from the website of the company HF Sensor. Just a few physical properties pass so manifold through our daily life as moisture. The value of moisture is in many areas one of the important features of a product. Moisture has high meaning for the quality of products, for their processability, or for the energy consumption during handling. This parameter often is neglected, although quick and informative moisture measurements can help to save high amounts of costs. In commercial organic processes, moisture content is, besides the temperature, the most important property. Decrease of moisture content below an optimal moisture content for the desired application leads to the death of microorganisms carrying the process, while exceeding the optimum range leads to fouling. Often billing systems rely on the knowledge of the moisture content. For example, in plastic recycling or in the use of biomass and wood chips. And it is not sufficient to know only the surface moisture, but also the moisture of the kernel. Microwave-based moisture measurements can do this and can do this very fast. For more details, especially also on the advantages of microwave-based moisture measurement against other types of moisture measurements, please see to the already mentioned website of HF Sensor. Moisture means water distributed in otherwise dry matter. The percentage of this water has to be determined. Let's briefly look to physics to see why just microwave testing is ideal to make moisture measurements. Here we see the dielectric properties of water. The dielectric constant or permittivity over the frequency from 100 megahertz to 100 gigahertz and at temperatures from 0 to 75 Celsius. At room temperature of 25 Celsius, it drops from 80 to less than 10. The reason behind this behavior is the molecular structure of water. And this drop coincides with a significant peak of the loss factor, which is shown here on the right-hand side. The loss factor at room temperature has its maximum at about 20 gigahertz. A high loss factor means that the transmission of microwaves in this medium is highly attenuated. And the higher the water content, the higher is the attenuation. So the measured magnitude of microwave attenuation in matter is a measure for its moisture. Such measurements can be done in the transmission mode and in the reflection mode. Especially the frequency region from 1 to 20 gigahertz is appropriate for such measurements because the underlying physical effect is rather high and the instrumentation cost is comparably low. In the following, we will see two videos showing microwave-based moisture measurement in practice, indoor and outdoor in agriculture. Let's start with the first video.
Water content in a product is important. Too much water can damage it, and too little of it means lower weight and less quantity to sell. Measuring moisture content online is crucial to be able to reduce fluctuations of moisture and to be able to keep the moisture level at a fixed target. The IntelScan moisture measurement system is based on a patented microwave technology. It immediately measures the moisture content in solids, for example feed pellets, pet food, fish meal, dairy products, and in powders. As well as measuring moisture, the system also measures density. Color changes, as well as different recipes of the product being measured, do not affect the continuous moisture measurement by IntelScan. In many cases, the same calibration can be used for different types of products, irrespective of density, color, or recipe. The unique feature of the technology is that a copolar microwave signal is transmitted through the material to a special reflector plate placed under the material being measured. The reflector plate changes the polarization and reflects the waves back to the sensor. The attenuation and phase change of the signal that's traveled twice through the material is measured. Based on this measurement principle, only one calibration setting is needed for many types of recipes, colors, sizes, and density. The main benefit of continuous monitoring of moisture and density content is that fluctuations in the process after drying can be reduced. Moisture level can be kept constant and control limits can be tightened. At this factory, samples were taken for analysis once every hour. The moisture level fluctuated considerably in that 1 hour. By reducing the fluctuations with continuous moisture monitoring, the target moisture content was increased without the risk of exceeding the moisture limits. This meant that this factory actually increased its production. Additionally, the factory is saving energy with better control of its dryer. There are 5 versions of the IntelScan moisture sensor available. The IntelScan Online, which is placed above products streaming along a moving conveyor belt. Information from the IntelScan Online is used to control the drying process. Online moisture measurement is now also possible for products inside a screw conveyor. A special sample tray places a smooth surface and even thickness of the material under the sensor before delivering the same sample automatically back into the process. IntelScan Silo is placed inside a silo where the product is streaming continuously for accurate moisture measurement. IntelScan Laboratory is a static version used for immediate analysis of moisture and density content in laboratories. The IntelScan Pipe is placed inside a pipe for accurate moisture and dry substance measurements. And finally, the IntelScan Bale, which is used to measure moisture content online in large bales or packs. Immediately knowing online the true moisture content of your products and using that information to your benefit means substantial savings in energy, as well as being able to consistently produce on a desired target moisture level. With IntelScan, you can stay on target.
And now the second video. Thank you for watching. See you next time. Goodbye.